Hi, my name is Michael Cho, and this is my Physics Impulse Momentum project on the topic of shin guards. Shin guards are used today in various sports and basically do what is implied by their name. A shin guard lessens the power of the collision and is worn in front of the athlete's shin to lessen the impact of any hit to the shin. Shin guards are used in a lot of sports today, but they're very common in sports such as MMA, soccer, taekwondo, and ice hockey. If you look down below, you can see shin guards from various sports which are made of various different things, such as plastic shin guards for soccer and foam shin guards for MMA. So what is the history behind the shin guard? The oldest generation of the shin guard was originally called a greave and was used by the Romans and Greeks during around 700 BC. The greave functioned as an essential piece of armor during battle rather than a safety device used in sports. Romans and Greeks used the greave to protect their shins during battle because they realized that the shins were an area susceptible to more pain. Although the founder of the original greave is unknown, historians know that guards of this time were made of hard metals such as bronze or gold and had designs of the gods, which the Romans and Greeks believed would aid them in battle. The overall function of the shin guards has not changed since 700 BC, except that today it is used in sports to protect our shins from balls or other legs rather than swords and arrows in battle. If you look at the pictures down below, you can see a golden Roman greave, a bronze Greek greave, and a greave found from the remains of Pompeii, which celebrates the god Bacchus. If you look all the way to the right to the Roman soldier, you will see what a Roman soldier wore during this time. So when was the shin guard introduced to sports? The shin guard was introduced to sports in 1874 by Sam Weller Whittleson, the father of modern shin guards. Whittleson was an avid athlete and played cricket for Nottinghamshire's team and soccer for Nottingham Forest. However, the rate of shin injuries were high at this time, so Whittleson reinvented the shin guards to be used in sports rather than battle. With the shin guard, players can maintain their safety while playing cricket and soccer. This shin guard was also later introduced to other sports such as MMA. Shin guards in 1874 were often made of polished wood, hay, or regular wood. As mentioned before, shin guards serve various purposes in various sports today. Shin guards are used to protect the athlete and keep his body as optimal as possible so he can have a long and healthy career playing with his team. This is why leagues like the NHL for hockey and the MLS for soccer require shin guards, and all UFC fighters require shin guards during training. If you feel your shin, it is hard because shins don't have muscles and tissue to protect you. It only has soft tissues and bone, which is why it hurts so much to get hit in the shins. Shin guards take a direct hit and provide shock absorption, which decreases the risk of serious injury. If you look below, you will see MMA legend Conor McGregor using shin guards, soccer legend Messi using shin guards, and hockey legend Jack Hughes using shin guards. So what is the physics behind the shin guard? All collisions using shin guards are elastic collisions. The equation for change in momentum in physics is P equals Ft with F being force and T equals time. And the equation for momentum is P equals mv with m being mass and v being velocity. Shin guards work by prolonging the time required to stop the momentum of the shin and the foreign object. The shin guard decreases the rate of change of momentum as well as increasing the time in which the collision takes place and absorbing some of the force of the initial hit. This decreases the force of collision for the shin. MMA shin guards have multiple layers of foam, which decreases the velocity of the foreign object as it travels through the layers. To understand shin guards, we could also look at some older physics we did back in quarter 1. Newton's third law says every action force has an equal and opposite reaction force. In this scenario, your leg is hitting a foreign object, and the reaction force is being applied on the shin guard rather than your shin. To better understand the idea in the previous slide of the shin guard decreasing the momentum of a hit to the shin by increasing the time of which the collision takes place and absorbing the force of the hit is seen through an experiment done in 2018. This experiment wanted to test the effectiveness of youth girls soccer shin guards and used 5 kg and 3 kg weights on shin guards to test it. The scientists used gravity to drop the weights on the shin guards, so using force equals mass times acceleration, with the acceleration being 9.8 meters per second squared, they dropped the two objects with a force of 49 newtons for the 5 kg and 29.4 newtons for the 3 kg. The scientists found that the final impact force of the weights on the actual shin, which was a traffic cone in the experiment and not a shin, was 12.93 newtons, and 5.44 newtons, a much smaller number than the original 49 newtons and 29.4 newtons. This shows how volatile the shin guard is when you're hit on the shin. This is another experiment done in which scientists measured the damage done by a kickboxing roundhouse kick compared to a taekwondo roundhouse kick. In competition, both these tested kicks did the same amount of damage to the opponent. Although the taekwondo martial artist's kick obviously delivered more speed and force, resulting in more power, it had the same impact on the opponent as did the kickboxer's kick. This is because in competition, taekwondo mandates shin guards, while kickboxing does not allow shin guards at the professional level, both of these people being pros, obviously. Although they are both delivering the same kick, taekwondo athletes train to and are used to kicking faster and with more force because their opponent will be wearing a shin guard, while in kickboxing, their opponent will not be wearing a shin guard. This shows the importance of the shin guards because the taekwondo martial artist had to deliver more speed and force to have the same effect on a protected opponent rather than a kickboxer against a naked opponent. The two gifs below aren't working, but if you look left to the equations, you will see the difference in power of these kicks, which had the same result to their opponents. The Taekwondo martial artist had a 136 meters per second velocity with a 2,300 Newton force. The kickboxer's velocity was 130 meters per second with a 1,600 force. Obviously, the Taekwondo martial artist had a stronger power in his kick, but in the end, they did the same damage to their opponents. This is my works cited with all my credible information and experiments, and thank you for watching my presentation.